When it comes to greenhouse gases, carbon dioxide is the one that gets all the attention, and it's not without good reason. According to the Intergovernmental Panel on Climate Change, carbon dioxide is the #1 driver of climate change. But methane is a major player in the climate change game, and the #1 source of methane is... You guessed it, livestock. Yup, cows are emitting gases that are warming our atmosphere. And it's happening fast.
When we look at the global warming impact on the 100-year scale, methane is 28 times as potent as CO2. But on the 20-year scale, it's about 85 times as potent.
Bill Gates has a reputation for investing in clean energy and lately has made news for backing a company called Rumen8.
Bill Gates is now joining the fight against cow burps and flatulence. The billionaire is investing $12 billion in an Australian startup which produces a seaweed-based feed for cows.
So how does red seaweed lower methane in cow emissions? And how in the world do we even measure cow emissions? The answer may be simpler than you think. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand weather and to love it as much as we do. In today's episode, I chat with David Brown, better known as Doc Brown. Now, this Doc Brown is more well-versed with methane than he is flux capacitors. So Doc Brown works for Spark Climate, a nonprofit organization working to find climate change solutions. We talked about why methane is a problem and the successful reduction methods that are happening right now. As I mentioned, Rumen8 seaweed pills are one of those methods. He's going to break down the science. It's pretty complicated, but he makes it very simple of how red seaweed can stop cows from emitting methane. And trust me, you're going to be able to impress your friends with this information after you're done listening. So sit back, relax, and join us as we go off the radar into the gassy world of methane with Dr. David Brown. I do a lot of interviews about climate change and greenhouse gases. So is methane something that we should have major concerns over?
Oh, I would say 100%. The methane contributes half a degree of current warming. And it's rising, and we don't have a really good way to control a lot of the sources of methane. So we can have good ways to control fossil methane, so from natural gas leaks, but we don't have a good way to control biological methane, so that's coming from livestock and rice fields and wetlands.
Can you talk about methane living in the atmosphere versus carbon dioxide living in the atmosphere and the difference there and how much is up there, how much is contributing to warming, but then how long both of those live as well?
Methane is what we call a short-lived climate pollutant. That means that every molecule of methane that goes up, about half of them will be gone about 12 years later. So this means that any methane molecule, you wouldn't expect to be there 30 years later. Carbon dioxide will stay up for hundreds or even thousands of years, right? If we put it up and we want to reduce it, we may have to find a way to draw it down. So we stop emitting methane, we'll stop having the impact. The issue is that when you look at methane, it's also very potent in the near term. So when we look at the global warming impact on the 100-year scale, which is a standard way of looking at it, methane is 28 times as potent as CO2. But on the 20-year scale, it's about 85 times as potent. And so that means in terms of near-term climate futures, which we're thinking about for 2030, 2040, and 2050, methane becomes a very important thing to solve quite urgently.
Okay, so it's the faster one, but also the more intense one.
Fast.
So where is it coming from?
Yeah, so methane is coming from a number of different places. The biggest place that it's coming from is livestock. The #1 is livestock. #2 is natural gas leaks. #3 is rice.
Can you address rice? Because that's a new one to me. How is it coming from rice?
Yeah. So we get methane produced when there's biology happening in a place where there's not oxygen. So when something is digesting like a sugar, like any sort of food you would eat, in the presence of oxygen, turns into CO2 and water. But if there's no oxygen, it can't become carbon dioxide because there's none of the oxygen in carbon dioxide. And what starts to get produced instead is methane. Rice is often flooded. So if you have a picture of a rice field, you can see a sort of flooded plain. And so underground, there's a lot of sugars being released by those rice roots, and there's biology eating it, and it can't make carbon dioxide because there's no oxygen. So it's making some methane instead.
Okay. And then kind of the fun one that we all like to talk about is the gas coming out of livestock. So let's talk about some burps and some farts. And how is this happening? Has this always been happening, or is it what we're feeding livestock in recent years that's made it worse?
Yeah. So it's always been happening. Animals that can eat grass have special digestion. You can't eat grass and I can't eat grass. Pigs and chicken can't eat grass, but grazers can. And that special digestion lets them break down the tough material. And that special digestion occurs without oxygen. So termites will produce methane. What's different is the scale of livestock agriculture compared to what the natural ecosystem was.
Okay. So it's being emitted from cows. And there was a study done in 2021 about this additive in seaweed when fed to cows can reduce methane coming out of them. First of all, how did this come about? Did somebody one day just say, well, let's just try seaweed? And did they try everything else and they just...
Yeah. I wish I had a good answer to that question. I don't know the story of how Future Feed first tried seaweed. I think there is some truth to that. We fed a lot of different things to cows to see what it would do. And there was some knowledge that certain sorts of chemicals that are similar to the one that's in the seaweed had an impact on methane. Very old knowledge from 50 years ago, but no one had tried the particular chemical that is in that red seaweed until the Australians did it. I think about a decade ago was the first study on that.
Okay, so they found this additive, and what is the additive, and what did they find it did?
Yeah, so red seaweed was the compound that they used, and the additive is a chemical called bromoform. It looks like methane, except it has one, methane is kind of like a T with a carbon and a hydrogen on each tip. Bromoform has bromine on one of the tips, and that means it goes to the place where the methane would come out of these microbes and blocks it up, and so prevents them from completing the production of methane.
How do they measure what the methane emission here?
Yeah. So there's a couple of methods. One of them is you put the cow in a box. Like literally, the cow is in a box.
That's what I was picturing, so it's good to know that's what it was.
Yeah. No, there's a couple others, but that's like the gold standard.
It gets to just marinate in there with his own gases floating around.
Well, they pump the gases out, fortunately, because that's what they want to measure. They're trying not to hotbox the cow. Yeah.
Okay. So this company that Bill Gates, this has made news recently because Bill Gates is backing it. Ruminate. What are they doing in order to kind of reduce this methane?
Yeah. So they're taking that chemical, and the issue with that chemical is it's a liquid, and it evaporates slowly, like slower than water does, but still you don't want the thing you're giving to the cows to disappear into the air. And they're formulating it. They're packaging it in a way so that it's stable, so that it's like a pill that you can give to the cow. And the pill will also be a slow release pill. So instead of it just having an impact, right when you eat it, it's kind of like there are many human drugs that are like this, where there's extended release. It's basically extended release methane blockers for cows.
And it's working.
Those are the statements that they're making and the reasons to believe. But like for scientists, there's a lot between the first study showing it working and something that's all the way to working.
Gotcha. But is this like something to be excited about?
Oh, it's definitely something to be excited about. And part of that reason is, if you have something that you can give to the cow once a day or less, so much easier. Imagine a cow that's grazing in a field, in a pasture. How are you going to put, seaweed in every bite that it eats?
Right.
You got to get to it when it goes to the milking parlor, feed it a supplement, send it out for the day. It's a much, much smoother way and much easier for farmers to adopt.
Yeah. Are we emitting methane too? Should we start taking these seaweed?
You do make a little bit of methane, but not nearly as much, right? So sometimes your biology has no oxygen in it, and you make methane, but it's not a big deal. I mean, if you're producing a lot of methane, you should go see a doctor. But
so if you eat a bunch of rice, are you producing more methane?
No, if you eat rice, you're not producing methane.
Okay, I'm a little scared about rice now.
Yeah, no.
All right, so I want to address. There's a lot of talk on social media, or at least there has been, about like Meatless Monday. And like ways to reduce your dependence on any sort of animal products as a mean to help climate. Is that a realistic thing? Is going vegan going to help the climate, I guess is what I'm asking.
The numbers are pretty clear that, a lot of that is true, that a lot of vegetable food and beans are more efficient. There's a lot of gradations in that, though. I mean, different fish or chicken produce a lot less greenhouse gas emissions than cows do as well. We can have a certain amount of cows grazing land, and there'll be a positive benefit for the soil carbon in that land.
How so?
So soil carbon builds up from root mass, and that is decomposing. So the cows come on and they eat the plants, and some plants die and new ones regrow. And this causes more root mass to be pumped into the ground, and some of that turns into soil carbon.
Interesting. Oh, tell me about Spark Climate.
Oh yeah, tell me about Spark. Yeah, so Spark Climate is a nonprofit, and what we look for is areas of climate solutions that we think are underdeveloped. Right, there's not enough people working on it. There's not enough ideas being pursued, and we try and help catalyze those fields, right? Through grants, through thought leadership papers, through talking to folks like you, Emily. And our areas of focus has been methane. So we're looking at two things primarily. One is this livestock methane question, because it's such a huge issue. The other is this question of, once methane is emitted, is there a way to reduce it, right? Can you capture methane from the air? Can you, if you have a very dilute leak, right? Not like your gas line breaking, but like just something that's a little bit of methane seeping out. Can we oxidize it out of the air and pull it out of the air right then? So it's both preventing cows from exhaling methane, and it's, if that methane's already out of the air, how do we get rid of it then?
So are there any really cool things happening as far as methane capture right now? Any exciting technologies? I heard something about methane eating Borgs. Are those real?
Methane eating Borgs?
Yeah. Somebody.
Oh my God. Yeah. There's a whole work on, this is like on the biology. There are microbes that eat methane, methanotropes. The Borg is a genetic element of how they work. So a really big question we have is, can we do biocontrol of methane and put a little biofilter where the gas flows in? Like, you could imagine even putting it in a barn, right? And the methane that's coming up on the top of the barn flows through, and little microbes eat it. And there's people trying to make structures that absorb the methane. And the interesting thing is, methane is natural gas, it's fuel. So if we can capture it, we may be able to then burn it for fuel. And in this sense, we have like a clean fuel.
Yeah. So it sounds like there's some parallels with what's being done with carbon dioxide too.
Yeah, exactly. And so a lot of it is thinking, hey, people have been really thinking about carbon dioxide removal, but let's look at the number 2 climate gas, which is a huge deal, and ask, how do we mitigate it, and how do we remove it too?
Cool. Well, Doc Brown, thank you so much. I learned a lot about methane today, and you made it fun as well. So I really appreciate that.
I appreciate the time. Thank you, Emily.
A big thanks to Doc Brown for making methane so fun. Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcast, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. If you know anyone that is interested in learning about innovative methods for reversing climate change, please share this episode with them. And feel free to rate and review us on Apple Podcasts and Spotify and let us know what you think of the show, or suggest new topics for us to touch upon in future episodes. You can find us on Facebook, Instagram, YouTube, Twitter. Just search the National Weather Desk. This podcast is produced, hosted, and edited by me. Special thanks to Eric Newell and Richard Cook for their contribution. I'm meteorologist Emily Gracie. Make it a great day.